All right, we're going to take a break from the complaining and go to something a little more potentially interesting, I guess. Apparently, someone proposed a model of three-dimensional time. I agree with this idea and a lot of what it proposes, but I'm not sure if our reasoning is the same for why. I also think that trying to put together a 3D time model is beyond our current needs and understanding and is ultimately unhelpful without first understanding the physical reality we are experiencing. And what I mean by that is basically like, as great as of an idea this is, I think it's way before its time, and we need to figure out what's going on, just the material plane of existence before we try and get into the temporal, plane of existence, right? We're trying, what I thought when I was looking at this, I was like, this guy's trying to fly before we can walk, right? I don't think that we're going to be able, I don't think it's wrong necessarily. I think it probably needs work, but I don't think we're ready for it. Because if this is right, I'm right. Right. And if they can't accept that I'm right, how are they going to accept this? I don't know. Listen, I'm pretty sure I would have to be right for this to be the case. I will say that I'm glad to see others thinking about such things, right? So I will say that the fact that anyone is proposing three-dimensional time, maybe it's not that weird of a proposal, but the fact that anyone's thinking about time in this way, is definitely interesting to me. It makes me feel a little bit better that at least I'm not the only one that's trying to, piece things together here. In theory, maybe like I said, I don't know if their reasoning for this being the case is the same as mine, but still, at least they're trying. I think it's funny that one skeptic of the theory said it couldn't work because it would be too unstable and life wouldn't be able to evolve or survive within it unless it was very cold. So, in this video that I watched talking about this, basically they brought up one of the main skeptics against it, which was also at one point one of their coworkers or a person that they did experiments with, or a collaborator in the past, and then they went from being their collaborator to one of their biggest critics or something along those lines, which I think is funny in itself. Basically, this critics, or whatever, said, well, this concept couldn't possibly work because it's just having three-dimensional time is just too unstable, right? And life it wouldn't be able to form, it wouldn't be able to survive, it just couldn't happen, right? The only way it would happen is if it was really cold and, if it was really cold and there wasn't a lot of movement and stuff, then maybe life could start to form, right? And I think that this is just absolutely hilarious because in this statement saying why it couldn't possibly be, they basically summed up why it is. Because I don't know how they don't see the irony in this, because our universe is very cold in comparison to the Big Bang, and considering all the solid matter and lack of diversity in bosons or whatever, I'd say it's obviously quite cold. Life wouldn't be able to survive in our universe unless it was very cold, which it is. So this is actually more proof than anything, right? So the argument was that time, there would be too much energy, it would be too unstable, it would be too chaotic, nothing would be able to establish, to form, to evolve, and life couldn't be, right? And because life couldn't be, we couldn't be, and if we couldn't be, then, obviously it's wrong, because we are, right? And so that's the argument. But the thing is that, if you look at what the start of our universe looks like, right, the quote-unquote Big Bang, and it's basically just insanely high levels of energy, right? And so, obviously, life isn't going to form in such a high density packed area because there's just so much energy, everything's flying around, it's chaotic, nothing can be stable for long because of just how much energy there is. Like, stability is just not favored, because what's the point of being stable when, you know, everything has energy, everything has tons of energy? There's no reason to conserve it, right? There's no reason to find stability. You don't need to be careful with your energy because there's just too much of it, right? And so nothing evolves in this high energy space, right? And so it's like, okay, nothing evolves in this high energy space. That's great. So as time goes on, you know, billions of years go by. Well, I don't know what the exact timeline is, but like, I think it's like some millions of years, and then boom, we get black holes, you know, in theory, right? Black holes form, they kind of suck in a lot of the energy and they go, yummy. And then what that causes is, it causes, you know, a reduction in the amount of energy that's actually available. And then these black holes start to pull in the energy, and the energy that is left starts to coalesce more because, you know, now there's not as much energy to go around. So now we got to start conserving, we got to start consolidating. And so that's what it does. And then we start to get galaxies, and we get star formations, and we get, you know, planets forming in different atoms, in, you know, building of the complexity of our universe, right? And so as this goes on, things get colder and colder and colder as matter collects more and more and more and gets more consolidated into points. Things get cold, right? And so what my other argument was is that the only time we observe, I'm pretty sure the right term is bosons, the only time we observe you know, there's 3 different types of bosons of each, like, there's 3 different flavors. I think that's what they use. The term is flavors, but I think a better term is phases, right? There's 3 different phases of bosons, right? And so my argument, which I've made in the past, is that these 3 different phases, where like, why are there so many flavors? These are phases of matter, right? Except in bosons, right? And so we only observe the smallest one because that is equivalent to solid matter and is what forms when things are cold, right? Because the universe is very cold. So we can only observe these different flavors of bosons in particle accelerators, where we make it very, 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 very hot for a short amount of time, right? That's when we see these bosons. But otherwise, they don't show up, right? They're not here because the universe does not have enough energy around anymore to sustain them, right? And so everything is solid. Everything's in a solid state of matter. All the bosons are in a solid state of matter, right? And so this is, again, evidence of just how cold it really is in our universe. It is very cold, right? And so this person is making this argument that it has to be very cold for life to emerge. And guess what? It is very cold. What cold is relative, right? But if you really think about just how much energy there was at the Big Bang compared to now, it's very cold. It's very cold. And so this argument that says it couldn't possibly work unless it's very cold basically is like, oh, well, actually, okay, well, that makes sense. It is cold and it does work. Okay, so this theory has some merit, right? Because if that's its limitations, if that's its restrictions, then that follows what we observe. And not that is all the evidence you need, but I just thought it was funny that I don't know if they intentionally did this, but the one like piece of skepticism that they put out there, you know, was the opposite of skepticism, in my opinion. And so, yeah, I don't know. I just thought that was funny, but also like interesting. And, you know, I like that, you know, I'm not the only person that's seeing the potential for time to be more than just this +1 dimension for us. And I know that other people have theories about time and stuff like that, but this is the first one that I've seen that like talked about 3 dimensions in a way. And as they kind of talked about, you know, kind of what they, predict and stuff, I was like, yeah, no, like, yeah, that's kind of what I think too. I agree with that. I like that concept. So I don't know, it was refreshing to see something, that I didn't hate. I just did like 3 videos complaining about quantum mechanics. You know, it was nice to see something that was like, oh, hey, that's kind of what I think. Um, you know, I don't. Anyway, peace out.